In this lesson, we are going to look at how do we predict chemical reactions. Or basically, we are given reactants, or maybe just one reactant, and from there we can determine what is the product that is going to produce from a reactant or multiple reactants mixed together. Now, before we go to that process, we need to look at the basic structure of any chemical reaction. First of all, we notice that the plus signs between products or reactant. Basically, the plus sign is used to separate one reactant or one product from another. Here we have two reactants, so we separate by a plus sign. Here we have two products, so we have to separate by another plus sign. Then, between the reactant and the product, we have the arrow. Now, there are multiple arrows that we need to look at. First, we have a single arrow, basically saying that it separates the reactant from the product, but it representing that when we have those reactants and mix them together, you would use or produce certain form of product. Then we also have another type of arrow, which is called a double arrow, where one goes in that direction and the other one goes the other direction. This double arrow represents the reaction is reversible. So what does it mean to be reversible reaction? A reversible reaction basically has reactant react together, make product, but those products can also react together to make the reactant. So it's going back and forth. Or we also have another arrow right here. On top of the arrow, we will have something on top of it, which in this case, we have this triangles. Now that triangle represents that heat is being added to the chemical reaction so that the chemical reaction can occur. So this triangle represents heat. Sometimes we could have something called an enzyme. This happens a lot in biology. An enzyme functions as a catalyst. And we know that the catalyst helps speed up the chemical reaction, but it's never being used up in a chemical reaction. And a common catalyst in chemistry is platinum, or sometimes a cheap one like MnO4. Okay, so this is a common catalyst that you will see on top of the arrow, like that. That would be for platinum, and right here this would be MnO4. There you go. So keep that in mind. Whatever on top will be the catalyst, or sometimes just heat being added to the chemical reaction. So before we start predicting the product, we first need to look at the reactant. What do we learn about the reactant? Before we can actually determine what products are being made from the reactant, we need to look at the reactants. Specifically, what ions are produced from the reactant, or in this case, if we have multiple reactants, what ions are produced from all of those reactants. Now, if we look at NaCl, we know that sodium is in group 1A, and here I have a quick summaries of all the common ions that you also have with you. I have a polyatomic ions list on the bottom here, and I also have the common monatomic ions in the specific group. Element in group 1A will produce +1, in group 2A will produce +2. In this case, 5 would have 3 minus, 6 would have 2 minus, and 7 would have 1 minus, in addition to the hydride, which is -1. So to do well in this section, you need to know the common monatomic ions as well as the polyatomic ions. So let's go back and look at the problem. What are the ions from the reactant? In this case, I know Na, that would be Na+. And Cl, that would be Cl, which is coming from chlorine in group 7, that's -. And for iodine, it would produce iodide ions. In this case, I-. Now, when we type this in our computer, of course, we need to use the caret symbol, which is this symbol right here on number 6 right there. So we go to number 6, you will see that caret symbol right there. We need to use the caret symbol to represent the charges from the rest of the chemical formula. Why do we use the caret symbol? Because the charges is a superscript. That is a tiny number on top of the letter. So in this case, we have Na. So we have Na. We have the caret symbol with plus. And for Cl would be Cl, caret symbol, minus. And for iodine would be the I and the caret symbol minus. And notice how the first letter for Na is uppercase and the second letter A is lowercase. Make sure when you type in it is case sensitive. That means uppercase and lowercase matters. So if you type in lowercase n and lowercase a, it would be wrong. Okay, so be careful with the case sensitive. Let's try another problem. Here I have calcium. That's in group 2A. So that would be right here. Okay, so that would give us Ca2+. And then we have ammonium NH4, and we go back to a list of polyatomic ions. Ammonium right here, NH4+. So we know it's going to be NH4+. Now, why do I care about the 2? Because when this become ions in a container, there's going to be a lot of ammonium, so we don't really care about that 2. That 2 is only tell us that, hey, what if I don't know what is the charge for ammonium, but I know the charge for carbonate, which is CO3 2-. If this is 2-, this ammonium must be plus because you need 2+ to cancel out that 2-, and that's the whole function of this subscript. So keep that in mind. How would I type this in the computer? Of course, I would put NH4 caret symbol plus, and for CO3 with CO3 caret symbol 2-, and that's all I have to do. Here I have hydrogen and bromine. In this case, we know that hydrogen can form a positive and a negative charge. But which one is the right one? So we had to go back and look at this one right here. This is bromine, and bromine can only produce a negative one. So this is Br-, and if this is minus, more likely this hydrogen will form a positive charges, because positive and negative combine together. Okay, and then let's go to another problem. Here we have calcium hydroxide. Again, we don't care about that too. But what if I know the charge for calcium is Ca2+, but I don't know the charges for OH. So in this case, OH must be what to cancel that 2+? It must be a minus. That would be -2, and -2 cancel out with a 2 positive. So that's the function of that number 2 again. And over here we have H3PO4. We don't know anything about H3, but we know this is a PO4. That is a phosphate. And phosphate, we go back to the list. That's right there. It's PO4, 3-. And notice how I make mistakes. That's supposed to be 3-, not -3. Okay? So keep that in mind. So in this case, I know PO4 is 3-, and hydrogen, each one of those must be plus. So those are the ions for this specific reactants. Let's try another one. We have MgO, magnesium oxide, which in this case, Mg is 2+, and O is 2-. Then we have water. This is very tricky right here. So water sometimes can be written as HOH, okay? So how does that work? This right here is represent your hydroxide. This is actually your OH- right here. And this one right here, HB, and this one right here, that would be your H+. So those are the ions in water. So be careful of this one, okay? And lastly, we have potassium, which is K. K is in group 1A, so it's plus right here. Right there, through there. And then H we know is already, it's going to be, and then we have HCl. Which one's going to be? Again, we know H can be either plus or minus, but we know Cl is minus. If Cl is minus, this H must be plus. And that's all we have to do when we have to determine the ions in the reactant. And then the next lesson, we're going to look at how these ions can be used to determine the products.